How long can a human survive in outer space? What would happen if you didn't wear a spacesuit when you traveled into space? Do not, under any circumstances, attempt to hold your breath. The lack of atmospheric pressure in space will cause your body's air to be drawn out. Your lungs will burst as a result if there is any air remaining in them. The remainder of your body's oxygen will likewise expand as a result of this. You will get far larger than usual, but there's no danger of explosion. Your skin has the right amount of elasticity to keep you together. Any liquid that is left exposed on your body will start to evaporate. Therefore, the tongue and the surface of your eyes will begin to boil. If you don't get any air into your lungs, your blood won't be able to deliver oxygen to your brain. You won't make it past the first 15 seconds of this. Asphyxiation will cause your death within a minute and a half following exposure. In addition, the temperature is extremely low. You will eventually turn into ice completely. This might take anywhere from 12 to 26 hours depending on where you are in space. But if you're anywhere near a star, you'll be completely vaporized in the meantime. In either case, the state of your body will persist for a considerable amount of time. Gut bacteria will begin to devour you from the inside out, but they won't be able to do this for very long, so your decomposition will be very gradual. There's a possibility that you could spend millions of years simply floating around in space without changing. Who knows? Maybe some highly developed extraterrestrial race may find you. What difference does it make if you travel to space in the same protective gear as astronauts? Does it have any effect on the body? Absolutely it will. However, technology such as that provided by a spaceship or spacesuit is able to shelter people from the worst conditions. Although many of the environmental conditions that humans will face during spaceflight are extremely different from those in which humans evolved, technology will allow humans to experience spaceflight. A life support system is a collection of technology that enables human beings to remain in environments typically inhospitable to their species, such as outer space. There are some risks that are challenging to manage, such as being in an environment with no gravity, which is also known as microgravity. Living in such an environment has a negative influence on the body in 3 significant ways. It causes a loss of proprioception, alters the distribution of fluid throughout the body, and accelerates the degeneration of the musculoskeletal system. Based on MRI research, scientists announced on November 2, 2017, that significant changes in the position and structure of the brain have been detected in astronauts who have completed travels in space. These findings came about as a result of the fact that astronauts undergo significant weightlessness during space travel. It was shown that astronauts who spent longer periods of time in space experience bigger brain alterations. In October of 2018, researchers who were financed by NASA discovered that prolonged trips into outer space, including travel to the planet Mars, may cause significant damage to the gastrointestinal tissues of humans. These new findings provide credence to past research, which suggested that prolonged exposure to conditions like these could cause considerable damage to astronauts' brains and accelerate the aging process. NASA released research in March 2019 stating that dormant viruses in humans may become active during space missions, which may add an additional risk to astronauts who are participating in future deep space missions. Without the proper protection, the atmosphere of space can be fatal. The absence of oxygen and pressure in space represent the biggest threat, but radiation, temperature, and other factors all present dangers. Embolism, hypoxia, hypocapnia, and decompression sickness are all potential side effects of being exposed to space for an extended period of time. In addition to this, there is also the possibility of cellular mutation and destruction due to the presence of high-energy photons and subatomic particles in the surrounding environment. During the extravehicular activities, also known as EVAs, astronauts face a significant risk of experiencing decompression. The current designs of extravehicular mobility units take into mind this and other difficulties, and they have developed over the course of time. The difficulty of deforming an inflated balloon in comparison to a deflated balloon is an analogy that may be used to describe one of the primary challenges that has been faced. The competing aims of improving astronaut mobility, which is hindered by high-pressure EMUs, and minimizing decompression risk have been a key factor. Investigators have taken into consideration the possibility of pressurizing a separate head unit to the same standard cabin pressure of 71 kPa, or 10.3 psi, as opposed to the current pressure of 29.6 kPa, or 4.3 psi, for the entire EMU. In a configuration like this one, the pressurization of the torso might be accomplished manually, avoiding the movement restrictions that are associated with pneumatic pressurization. When astronauts are outside of the protective influence of Earth's atmosphere and magnetosphere, they are subjected to dangerously high quantities of radiation. Damage caused by high amounts of radiation to lymphocytes, which are cells that play a significant role in the maintenance of the immune system, is a contributing factor in the decreased immunity that astronauts endure. Recent research has also established a connection between radiation and an increased prevalence of cataracts in astronauts. Outside of the shelter of low Earth orbit, galactic cosmic rays create additional hurdles to human spaceflight. This is due to the fact that the health risk posed by cosmic rays dramatically increases the likelihood of developing cancer after being exposed to them for 10 years or more. According to the findings of a study that was funded by NASA, astronauts may be at increased risk of developing Alzheimer's disease due to exposure to radiation. Even though they are uncommon, solar flares have the potential to deliver a lethal radiation dose in a matter of minutes. It is speculated that protective shielding and protection medications may ultimately minimize the hazards to an acceptable level in the end. Because the magnetosphere deflects solar wind around the planet and the International Space Station, the crew members who live aboard the ISS are afforded some kind of protection from the hostile space environment. However, solar flares are capable of warping and penetrating the magnetic defenses, and as a result, they continue to pose a threat to the crew. In 2005, the crew of Expedition 10 took refuge in a more extensively insulated area of the station that was specifically intended for this reason. This was done as a precaution. However, outside the modest protection provided by Earth's magnetosphere, human trips to other planets are significantly more susceptible to danger. Researchers from the University of Tennessee, led by Professor Lawrence Townsend, together with other researchers, have analyzed the most powerful solar flare that has ever been documented. The acute radiation illnesses and even death that could befall astronauts as a result of the radiation doses that they would receive from a flare of this magnitude is possible. It has been established that human health can suffer when people are subjected to conditions in which they do not experience gravity. And that's all for today, guys. I hope you enjoyed the video. Thank you for watching, and we'll see you next time.